to our presentation. We are group number 3, and this is for CS643's application project. My name is Anthony Costa, and my group mate is Razmi Pavani Katabatuni. We decided to use parallel processing to determine the value of census data when creating policies in the future. We also wanted to understand the power of data discovery in real time by using parallel processing. It was actually pretty interesting. Like I said, before we use census data, we needed to figure out what kind of structure we wanted and how we wanted to distribute the data when making the project. And also in terms of speed, we were trying to compare a single node versus a multiple node query. Our output was going to be reports such as one of our inputs could have been show me the average age of doctors in the state of California that make over $150,000 in a year. So the report would show us the average age, and also you could run multiple queries, multiple statements such as that to run multiple outputs, and that we can create in a report. And therefore you can give to, let's say, the government, and they can figure out exactly if they wanted to in the future a certain state tax for a certain profession, such as a doctor. With these report outputs, we wanted to determine if they were A, necessary, B, reliable, and C, are they valuable, right? Why would the government want to know, for example, how many guys in the state of Arkansas are under 27 and have a college education? That doesn't really determine a whole lot of value in creating policies. To validate, there's a bunch of information on census data, so it was easy to compare our outputs to reports that are readily available. And by comparing that, we could also determine if there could be a policy change that is necessary. Our design was to create 51 AMIs, and we chose to use MapReduce using Hadoop. 51 as in the 50 states would be the slave AMIs, and 1 master AMI, of course, because basic design. You want to load the census data into a single node, or you can load the census data into the 50 nodes, the 50 states, if you will, and we execute queries on both configurations. We couldn't exactly get our setup to work, full enclosure, so All of our results are based off of simulations and calculations that I've done. It's not actual results from our setup. Based off of my calculations, I determined that multi-node is obviously faster because it is able to spread all of the configurations across the board instead of one node talking to 50 to grab the results and then sort them and set them up the way you exactly want. This is obvious. It's a well-known fact. Our evaluation, both both completed without failure, which is great. That means single node is very reliable. It is effective, but multi-node is faster and it's easier to scale, and the speed is obviously quicker. Our conclusions are that multi-node was more positive than single node. Barely any failure. The results came back as excuse me, favorable and valuable based off of reports that are out there. The calculations were pretty similar, and it could help in policy change in the future. And the reason why I wrote at the bottom there that information results do not correlate with policy implementation means that what is currently happening now is not the same as the results that we got. Even though the reports show similar outputs, the government is not using those the way that my partner and I believe that they should be handled. Thank you for watching our presentation. If you have any questions, feel free to ask. I'd like to thank anybody who's watching, and have a good day.